All right, lesson 12-2, we're going to be adding, subtracting, and multiplying our radicals together. So before we get there, because we're going to be using some funny words down here, we're going to kind of go through parts of a radical. So we call the root, I call it the root, but technically the true name for it is called the index. So if we're looking at which root it is, that is called the index. So we'll use the word index, and I sometimes forget and use it, the root, but that is it. The symbol right here, we've already talked about that symbol. It's called a radical symbol, a radical, but the number or the value that's underneath the radical right here, we call the radicand. Radicand. All right, hopefully you'll all remember this, at least for today. Okay, and then we already talked about this as well, but if there's no index, so if they don't write a number right there, it's assumed that it is a 2, that it's a second root right there. All right, so here's the rule. When we're adding and subtracting radicals, you're going to, first of all, before you do it, you're going to simplify all the radicals. This is because you can only combine, when you're talking adding and subtracting, we can only combine or add and subtract radicals that have the same index. Actually, let's go back up here. So they've got to be the same root. So that means you cannot add square roots to cubed roots. You cannot add square roots to fifth roots. You can only add square roots to square roots. So they've got to have the same index and the same radicand, whatever number is under here. So you can only add square roots of 2 to square roots of 2. You cannot add square roots of 2 to square roots of 5. Okay, you cannot add square roots of 7 to square roots of 8. Okay, you can only add, they've got to have the same index and the same radicand to be able to add them together. Okay, all right, so example 1 right here, notice again, we're supposed to simplify very first. This is because right here, they both are the same index, but they're not the same radicand. 27 square root of 27 and square root of 12, you're thinking, well, you just told me I cannot add those together. I cannot subtract those. However, watch what happens. When we simplify them, they actually turn into having the same radicand. So let's go ahead and look at this one together. So this 3, remember the square root of 27. 27 can be written as 9 times 3. So when we go through to take the square root of each of those individually, this is a 3 times the square root of 9 is 3 times the square root of 3. 3 times 3 is 9 square roots of 3 right there. So I can simplify 3 square roots of 27 and 9 square roots of 3, same thing. All right, now look at minus 2 times the square root of 12. So 12 again can be simplified, just like the 27, it's 4 times 3. So when you take the square root of both of those, you've got a negative 2 times 2 square roots of 3. So this will be a negative, or subtract, and then 2 times 2 is 4, square roots of 3. Now, when you're doing this, you only add, subtract the coefficient. You keep whatever the radicand was, in the radical. So you're going to keep the square root of 3. You're just saying, I had 9 of them, somebody took 4, so I'm left with 5 of those square roots of 3. So do not add the 3's. Do not subtract the 3's. Those stay. You just subtract the coefficients there. 9 subtract 4. All right, let's try another one. Let's look at this next one. Let's do a pretty blue. Okay, again, you've got to simplify first. Okay, this is actually, this whole lesson is just another day of you guys practicing simplifying radicals. That's the hardest part of this lesson. The 9 subtract 4 is not hard for you, but getting the 3 square roots of 27 and 9 square roots of 3, that just gives you extra practice. All right, so right here, the cubed root of 54. Now, 54 is not on my cubed list, if you guys have those there, but I remember that 27 times 2 is 54, and 27 is on my cubes list. So when we go through and take the cube root of both of those, this goes to, the cube root of 27 is just 3, because 3 times 3 times 3 is 27, and then we're going to keep that cube root of 2. So, we almost have the same thing. 3 times 3 is 9, and then we have the cube root of 2 right there. All right, we've got a cube root of 2 as well right here. I don't even need to simplify that one. I can't simplify that one as well, so I'm just going to write it down here again. So I'm going to subtract subtract 2 cube roots of 2. And then right here, let's go ahead and do the 7 times the cube root of we're going to rewrite 16 as negative 8 times 2. All right, when we go through to simplify this, we've got 7 times the cube root of negative 8 is negative 2. Since negative 2 times negative 2 times negative 2 gives me that negative 8. I just undid that, went backwards. And then I've got, oops, that's supposed to be a cube root. Then I've got the cube root of 2 right there. So 7 times negative 2 is negative 14 cubed roots of 2. Very good. Now, remember, guys, all you're doing is adding, subtracting coefficients. Okay, so 9 subtract 2 is 7. 7 subtract 14 is negative 7. And then you're going to put back in your cube root of 2. So you got negative 7 cube roots of 2 right there. The adding, subtracting, easy stuff. It's the simplifying radicals that you got to work a little harder at. Okay, try this one. We've got 28, square root of 28. Again, look for your your index first or your root first. So it's a square root. So I know 4 will divide into 28, and 4 is a perfect square, but it's not 4 times 28. It is 4 times, yes, that's right, 4 times 7. Okay, so now when we take the square root of both of those individually, we've got 10 times 2 times the square root of 7, which is 20 square roots of 7 right there. All right, 56, and look this time, and you're probably, alarm bells might be going off in your head because you're saying, didn't you just tell me that they have to have the same index? Yes, still simplify it. Okay, we still want you to simplify it. Notice that step came before this one. Still simplify it, but don't add them together. All right, so cube root of 27 won't divide into 56, so it's got to be 8. So let's write this as negative 8 times 7 right there. Oh, look, there's our 7 too. Okay, so we're going to take the cube root of both of those right there. So the cube root of negative 8 is negative 2. And then we've got that cube root of 7 right there. And right here for this last one, negative 4. And then I'm guessing it's 7 again. Sometimes you'll see a pattern here. But I know 25 times 7 is going to give me that 125. All right, when we take the square root of both of those, I've got a negative 4 times 5 times the square root of 7. So I've got negative 20 square roots of 7. Very good. Now, again, only combine those that have the same index. So we're just looking at our 20 square roots of 7, subtract 20 square roots of 7. So I actually have 0 square roots of 7. I had 20, somebody borrowed 20, so I have 0 square roots of 20, or 0 square roots of 7. So I just need to write down that negative 2 cubed roots of 7. That doesn't combine with anything, so it's just going to stay. That's our answer. All right, that's it for adding and subtracting. We'll multiply in our next video.